Hello everyone, welcome to part A of our internal assessment 1 of data science review. In this video, we are focusing on the statistical characteristic of feedback data. Before we can analyze trends on or make predictions, we must first understand the fundamental shape of our data. We'll start with question 1, exploring the three key measures of our disposal functions of our data: range, interquartile range, which is IQR, and statistical deviation, and why knowing the difference is crucial for handling outliers. Then in question 2, we will take a sorted data set and build a complete test statistical profile, calculating everything from mean and median to constructing a box plot and QQ plot to check for normality. Finally, in question 3, we will take a real world scenario based finding the approximate median from a group frequency table when no exact values are available. So let's dive into the numbers. Hi everyone, in this video we are discussing part A of our data science internal assessment 1, which focuses on statistical characterization of feedback data. Here comes the questions. Question 1, measurement of dispersion and efficient computation. Let's talk about three commonly used measures of dispersion when analyzing student feedback data. So first, let's talk about what dispersion actually means. Dispersion simply means how spread out the values are around the average. The first measure is the range. The first measure is the range. The range is the difference between the highest and lowest values. Its formula is range is equals to maximum minus minimum. The This measure is extremely easy to compute and works well even for the large data sets because it requires only a single pass to find the minimum and maximum values. However, the range is the range is very sensitive to outliers. So let's just talk about what outliers are. Outliers are the values which are very small, or yeah, we can say that they are extremely small than the minimum value present in a data set, or the values which are very much high when comparing with the maximum value present in the data set. For example, one extremely high or extremely low feedback rating can distort the range. The second measure is the interquartile range or the IQR. IQR represents the spread of the middle 50% of the data. It is computed using the formula IQR is equals to QS minus QS dash, where Q1 is the 25th percentile and Q3 is the 75th percentile. IQR is robust against outliers because it ignores extreme values. The third measure is standard deviation. This is most widely used measure of dispersion. To compute, we follow these steps. The step 1 is compute the mean of data. 2 is subtract the mean from each observation. Then we square these deviations. Step 4 is compute their average, which is their variance. And the final step is take the square root to get the standard deviation. A small standard deviation implies that feedback scores are very consistent, while a large one indicates high variability. So, efficient computation in large student databases. For massive data sets, these measures can be computed easily using SQL aggregation functions or streaming algorithms that process the data in a single scan without loading the entire datasets into the memory. This makes them suitable for large-scale student feedback analytics. Coming up on the question 2, which is complete statistical summary of sorted feedback data. In this question, we are given a sorted list of feedback scores ranging from 13 to 70. Using this data, we have to compute several statistical values. First, let's compute the mean. The mean is calculated as the sum of values divided by the number of values. We add all 26 values together and divide by 26. That gives us the average rating. Next, the median. Since we have 26 values, the median will be average of the 13th and 14th value in the sorted list. We simply take two middle values, add them and divide by 2. Now the mode. The mode is the value that appears most frequently in the given data. The value 25 appears 4 times while the other value appears fewer times. So mode is 25 and the data is unimodal. The mid-range. Mid-range formula is maximum plus minimum divided by 2. So we take 13 and 70, add them and divide by 2 to get the mid-range. Now the quartile. Q1 is the 25th percentile and Q2 is the 75th percentile. Using positional formula, we estimate Q1 and Q3 from the sorted list. Then we have 5 number summary. It includes minimum value, Q1, median, Q3, and maximum value. Coming upon the box plot. A box plot visualizes the minimum Q1, median Q3, and the maximum along with the potential outlier. Finally, box plot, sorry, finally the quantile plot versus QQ plot. Quantile plot simply shows our dataset's quantities on the y-axis against their proportional position on the y-axis. A QQ plot compares our data's quantities against those of a theoretical distribution, usually the normal distribution. If the points lie roughly on a straight line, it indicates that data is approximately normally distributed. Now, coming upon the question 3, approximate median from the group frequency table. In this question, we are given a student lab infrastructure satisfaction scores grouped into class intervals along with the frequencies. Our task is to compute the approximate median score. So we'll do it step by step. Step 1, prepare the cumulative frequency table. The intervals and the frequencies are as follows: 1 to 5, 200 students; 6 to 15, 450; 16 to 20, 300; 21 to 50, 1500; 51 to 80, 700; and 81 to 110 is 44 students. Total number of students when we add up all the frequencies comes out to be 3194. Coming up on step 2, find the median position. Median position is equals to n by 2, which is 3194 by 2, which comes out to be 1597. Now step 3, identify the median class. Cumulative frequency up to 16 to 20 is 950. Cumulative frequency up to 21 to 50 is 2450. Since 1597 lies between 950 and 2450, the interval 2150 is the medium class. Step 4, apply the group data median formula, which is median is equals to L plus n by 2 minus CFV upon FM into W, where L is lower boundary of the median class, which is 20 by 50 from a data set. and n by 2 comes out to be 1597. CFB stands for cumulative frequency before median class, which is 950. FM is frequency of median class, which is 500, and W is class width, which is 30. Step 5, which is substitute and compute, which is purely our calculation part. From our median formula, we have 1597 minus 950, which is 647. 647 upon 1500, which is 0.43 of 13. 431 0.4313 into 30 comes out to be approximately 12.94. And finally, the median comes out to be 20.5 plus 12.94, which is 33.44. Again, an approximate value. So the approximate median score is 33.44. This value represents the central tendency. This value represents the central tendency of student satisfaction for the group distribution. So we are done with part A. In the next video, we'll cover with part B and the other remaining parts. And that concludes part A. We have successfully broken down the core tools used to summarize student feedback. We have learned that while the range is easy to calculate, it is sensitive to noise, whereas the IQR gives a robust view of the middle 50% of the students. We have also walked through step-by-step process of using cumulative frequencies to pinpoint the median class and group data, which is a vital skill for handling large aggregated reports. So remember, these descriptive statistics are the foundation. If you cannot accurately describe your data, you cannot compare it. So review the formulas for the group median carefully. In the next video, we'll take the concepts further. So to see how we can compare different student profiles. So see you all in part B.